Oh, yes.
Where's Rachel? Where is she? Where'd you... Harvey? Where did you put her? Where did Harvey put Rachel? Hello. Hello. You're watching Nerdish. I lost my shoe. You gotta put your shoe back on. Very good. What are we doing here? Well, we do SAT, ACT prep for everyone. Yes, and the question is not where is Rachel, but when. 8 to 9:30 p.m. That's when Rachel is. Tuesday, Wednesday, and Thursday. Watch it. Just see what it's like. It's for free. All week long. You can ask us questions like where's Rachel and what you do with Rachel and where is Harvey Dent. They're both studying for the SAT. It's a very important test if you want to go to college or university. Nice. I should have said university first because it rhymes. Oh, that's Catwoman. That's okay. I think we know Catwoman because we're Batmen. Let's do a problem. Yeah. We did exponents last time. What should we do? Let's factor a quadratic. Okay. Man, okay. When it comes to education, I'm an addict. Oh my god, but not that kind of addict. No, just a quadratic addict. I hope this is factorable. Oh, it's gonna be factorable. Add 6. Okay. 6 is for Rachel. Alright. Let's take out a 2. Let's make it equal to 0. That's a good idea. Okay. So let's factor 2. X squared minus 2. How much time do we have before Rachel explodes? Ask Harvey. Harvey. Multiply to positive 3, add to negative 2. I don't think that's possible. Oh, shoot. That's okay. Sometimes you can't factor quadratics. And sometimes you can't save Rachel. I was about to say that. I'm so sorry. No, it's good. It shows that we're tight bonded, like Tight Bond, original wood glue. It has a tight bond, like me and Levi.
Durander. Well, hold on. Okay, they just subscribed.
Jeez.
1 second.
What? Do you even know Brady well enough to say that? That's... Okay. You know what would... I mean... the answer... Okay.
Well done, Durander! Well done!
That guy's got to have a name.
Yeah, you're right.
He's like the well done guy.
Wait, who is this? Wait, Durander. I love you too. I don't know. Who are we? Who are we? Durander. Dear Ander. Durander, you must tell me who you are.
Duran. I don't know.
Yeah, it just keeps going.
Yeah.
But it repeats, so it's a rational number.
Right.
Rander. Duh. Rander. Who are you? Identify yourself, coward. Sorry. Just here to learn. Yeah, I understand that.
Okay, what do you want to learn?
We're all here to learn, but you must tell me who you are. You don't have to, but
Do you truly deeply know Brady from Brady's past, or you know Brady from this?
from
Brady?
streaming, yeah. Because stream Brady and past Brady, two very different things. I mean, Levi can attest to
I
that.
can attest.
Oh my God, Levi, when he got me on the stream, he really cleaned me up.
I don't know what that
I just
emoji
think that
means.
looks like Steve Bannon. Doesn't it?
I don't know what he looks like.
You don't know? Are you serious?
I don't know what he looks like. There are lots of guys.
Do you know what a president looks like?
Yeah,
Right.
It looks like Steve Bannon.
It's going off the screen.
I know. I decided to do that on purpose.
Why would you do that?
I think it's funny. Makes us look very unprofessional.
That's great.
Speaking of, I need to post on Facebook.
You post
Hey.
on Discord?
Huh?
You post on Discord?
No, that's your job.
You're right.
We don't condone violence.
I know.
Is this mine? Give me.
No!
Durander, what would you like to learn, SAT, ACT wise, or about Brady's personal life?
it's very personal as of late.
Very personal and lively.
Yes, I would say, and vibrant.
Vibrant.
Abundant.
You have a very abundant personal life.
I would say that.
It is. I can't make sense of that idea.
That it's abundant?
Yes.
Why?
Because that implies multiplicity.
Well, it's a wealth of. I mean, I think some people, everyone has one life, right? And it's a mixture of personal and public life, right? So I guess if I have a very rich, abundant personal life, that means my public life must be a lot smaller in comparison to some people.
Okay.
Right?
Mm-hmm.
So I guess that's what it means, is that I have a very small public life, which is
No,
why
it
I
still
don't.
doesn't make any sense.
Well, it's why I don't do things like, go on like social media a lot and like project myself so that people can watch. I don't do that kind of stuff.
No. Brady, do you know where you are?
The Muffin Man?
No. He was married to the Muffin Man.
The Muffin Man.
The Muffin Man!
He's married to the Muffin Man?
The Muffin Man!
Ring Matthews!
Ring, what's up?
One ring to Matthew them all. One ring to Matthew. And in the Matthew, bind them. I know the whole thing. I skipped a line.
Matthew, do you have any questions?
Got any questions, Matthew? You good by math? So we're about to do math. Talk about math.
Nice. Good segue. You gotta start graphing rational functions.
What
dude.
if I punched you? But what I did, hold on. I wound
don't
up.
like this
Don't
at
worry,
all.
no. I wound up and I just started it like on your head,
No,
and I
Kelly
went
hurt my
like
neck.
this. What if I did that?
I don't know.
I just did it, so clearly we know what if.
I didn't like it.
You didn't like it.
Oh, it made me feel unsafe.
You may not like it, but I like it.
You don't like it.
I
deep
do.
down.
I like it.
You only like what your business partner likes.
And what's wrong with that, huh?
Okay, dude, start graphing rational functions.
Fine. Jeez. Wow.
Do you know what? It's like an asymptote, right?
Kind of. Yeah, I would say that.
Yeah, it's. You know how you always go through the asymptote?
Right. I suppose that's right. All right. So this is a rational function. It's got some with x on top, some with x on the bottom. We call it rational because the root of that is ratio. We have a fraction. Ratio. Oh. Okay. Anyway, if we wanted to graph this thing, well, let's first take a look at it. We got something on top, something on bottom, but they're the same thing. All right? 6 over 6 is equal to 1. No pref. You do you. All right, we'll do us then. Very good. 6 over 6 is 1. Something over itself is 1. So x minus 1 over x minus 1 seems to be 1.
Why not 3, my lord?
Eat your yodels.
Yes, my lord.
Okay? So y equals 1 looks a little bit, actually it looks a lot of it, like this. Here we go, we got y is 1. There it is right there. I should probably do it with a different color so you can differentiate it. That's what y equals 1 is. So it seems like it would be this one. You plug in any number, 4. 4 minus 1 over 4 minus 1. 3 over 3, that simplifies to 1. So this seems to be the graph, except, it is mostly the graph of y equals 1, yes. But there is something we have to remember here. X minus 1 is on the bottom. There is something that you cannot divide by. We can't divide by 0. So x minus 1 can be anything we want it to be as long as it is not 0. If we set it equal to 0, we'll find out what x value we can't have. That x value is positive 1. We can't have positive 1. Okay, that is the one value we can't have. If we plug that in, that's going to be 0 over 0. You can't have 0. I mean, you can have 0 on the top, that's fine, but you can't have 0 over the bottom. Okay, so what's going to happen here is there is one place where we cannot have our function defined, and that's at x equals 1. So what we're going to have here is called a hole. There's a small hole here at x equals 1. Okay, that's a slightly larger hole. It's infinitely small. It's a tiny little, because you can have 1.001, you can have 0.9999. You just can't have exactly 1. Okay, but for all other numbers, they'll always cancel out on the top and bottom, giving you 1. So this is a hole. All right. Introduction to rational functions. We got holes. We got things that are canceling out. It's a lot of fun. All right. A lot of things to think about with rational functions. All right. We're going to start off with. Well, we start off with that, right? We can't start out with something else because we already started. But here's the next thing. Let's see what we get here. We're going to have y is equal to x plus 2 over x minus 3. There's no cancellation happening here. There's just not. So we can't do any of this whole business. You get a whole when you have a 0 on the top and bottom that match each other. All right, we'll come back to that in a second. All right, let's talk about what this would look like. All right, so the first thing you should notice is that we cannot divide by 0. You just can't do it. Okay, so what value would we have to have x be for this to be divided by 0? You set the bottom equal to 0. You solve. X can't be 3. X can't be 3. So does that mean there's a hole there? No. The hole happened because they canceled out on the top and bottom. It's always going to be 1, except for when x is 1. Okay? In this case, let's think about what's going to happen when we get closer and closer to dividing by 0. All right, so we have x plus 2 over x minus 3. Let's say that we have, I'm going to make a little table here. Make a little table. You know what? No. I'm going to do... No, I was a little table. All right, so x can't be 3. So we're going to say we got 4, we got 3, we got 2. See what's going to happen. So if we have x equals 4, 6 over 1, that's going to be 6. We know it's undefined here. We put 2 in there, we have 4 over negative 1, which is negative 4. Okay, interesting. Let's get a little closer. All right. So 3 is what we can't have. 3.5, 3.4, 3.3. We're going to start closer, actually. Start a little bit closer. We're going to go to 3.1. We're going to go to 3.01. We're going to go to 3.001. So as we approach 3, which we cannot have, what's going to happen to the value of this function? I need to fire up the old calculator. Levi, I swear, is this thing like gas powered? Do you have to fill this up with gasoline?
Yes.
Makes sense. Okay, this thing is dead. Can you pass me my phone? Sorry, everyone.
Hey Siri.
Thank you, Levy, I guess. All right, now wait a second. Okay. So what we have here is on the top of 3.1, that'd be 5.1 divided by 0.1. Which gives us, it's a big number, 51. The next one, we have 5.01 divided by 0.01, which gives us 501. And then lastly, we have 5.001 divided by 0.001. It's getting huge.
Hey Trapesy, sorry. Yeah, we can't no profanity, sorry.
Sorry.
Yeah, I had to block it. I
had to block it.
I've said sorry a couple times, and I realize I don't mean it at all. I just, yeah, it's me. What's up?
Levi is disappointing. Welcome to my life. Psh.
Bird, stop that.
What?
It hurts me.
It hurts you. We don't condone violence.
I hate that so much.
It's okay because we don't condone it.
Bird, I still get violenced. I was going to say violated, but that's not quite what I want to say.
Get violence, get out of here.
Okay.
Just go. You disappoint me.
Violence is not prohibited. I mean, it is. Double negatives.
Dude,
you have to teach that, Bird.
I think you just told them that you condone violence.
No.
Anyway, guys, stop getting us distracted. The closer we get to dividing by 0, the more incredibly large these numbers get. If you divide something by 0.000001, you divide it by something that's really, really small, your answer is going to be massive. So what we have at x equals 3 is called an asymptote. All right, x equals 1, x equals 2, x equals 3. This is a vertical line.
Right.
Yes, I do know what the Mandelbrot set is.
Whisper it into the microphone.
An asymptote.
Yes. All right, which is a line that x cannot be, that we are going to eventually cozy up to as we go up. The Mandelbrot set. What's that like little thing that looks like this? And it's got the same, it's like a repeating thing. Yeah, something to do with imaginary numbers. It's a solution to an equation that's like has an imaginary number in it. Yeah, Trapsy TV. Why TV? Are you on TV or something? Anyway, that's our asymptote, a vertical asymptote. A vertical asymptote is created when you divide by 0. Unless it's a hole, then it's a hole. Okay, but if we're dividing by 0, we get a vertical asymptote. That's the first thing. Okay. Now let's talk about x and y intercepts. All right. These are not really that difficult because you've done x and y intercepts before. If you want to find an x-intercept, When you're crossing the x-axis, your y is equal to 0. So you set your equation equal to 0 and find what your x values are going to be. So 0 is equal to x plus 2 over x minus 3. Spoiler alert. If a fraction is equal to 0, it is the top number, the numerator, that gives you 0. The bottom number is 0, you're out of luck, you're dividing by 0. But if the top number of a fraction is equal to 0, then the whole fraction is equal to 0. So really, it's just the top here that we care about. X plus 2 is equal to 0. You can multiply the x minus 3 to the other side, but when you multiply by 0, it goes away. So we just have 0 is equal to x plus 2. So x is going to be equal to negatron 2. Negatron 2. That is our x-intercept. So I'm going to put that on. We got -2. X-intercept right there. Fantastic. We're doing great. We're doing great, Trapsy. Keep it up. The y-intercept happens when x equals 0. All right, so we just plug it into the equation. We got 0 plus 2 over 0 minus 3. That's -2/3. All right, that is our y-intercept right there. -2/3. So if that's -1, -2/3 is right around there. Great, 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 great. Okay. We've talked about vertical asymptotes. We talked about intercepts. Now we got to talk about horizontal asymptotes. Bum, bum, bum.
Also, Robot Dancer, we saw your questions in the Discord, and we will get to them just as soon as Bert is done with graphing rational functions.
Jacob,
Yes?
get out of here.
You really like that drink.
What?
Jaga?
Yeah, it's a great drink.
What is it?
What is it? It's pure.
Isn't it like fermented cow's milk or something?
It's undiluted. It's the stuff of life.
You don't answer my questions.
You ask questions that don't make any sense.
That's not true.
Robot Dance has got a lot of questions. All right, listen, we're just gonna finish this, and then Robot will start with your questions. Does anybody want to know more about rational functions? I will finish this one right here. But if anyone's like, I need to know more about rational functions because I don't know what they are, I don't know how they show up on the ACT and SAT, let me know, and we'll make sure to really give this concept a good run for its money. But we're not done with the concept anyway. We could just do a diet version, which would end soon, or we could go full on, and yeah, it's up to you guys. Okay, so the horizontal asymptote. Similar to a vertical asymptote, because it's a dotted line that your function approaches. One of the differences, though, is that you're allowed to cross it. You can't cross a vertical asymptote, but you can cross a horizontal asymptote. It's allowed. Here we go. I love this blue. It's such a great blue. And what you want to think of for a horizontal asymptote is what is going to happen as x approaches infinity, or just as x gets very big, okay? So our function is x plus 2 over x minus 3. If x gets really, really big, what does this function approach? Well, think about what terms stop mattering, all right? If x is massive, the little plus 2 here, it's very dinky. It doesn't even really matter anymore, okay? X, what?
Dinkword.
Thinkword, dinkword. X really starts to take the spotlight as x gets really big. So what this is going to turn into is x on top, and -3 is the same. As x gets very big, the -3 really stops mattering. So it's going to be x over x, which we know is equal to 1. So we have a horizontal asymptote at y equals 1. All right, the horizontal asymptote doesn't really affect your graph where all the action is happening, but on the far reaches, that's where we start approaching 1. When you're done, can you explain the Mandelbrot set? Yes. Yes, we can. Yes, we can. Okay, so we have a horizontal asymptote at y equals 1, which is right here. All right. We're actually ready to graph this thing, okay? If you've ever seen rational functions, they do fun stuff like this. They, oh, yeah, that's not what I wanted to do. They do stuff like this. You got horizontal asymptotes. They get really close to these asymptotes. So you kind of have to see a couple to start getting the hang of these things. But from these 2 points here, we know that we're underneath the horizontal asymptote over here, and we're approaching this vertical asymptote. So there's really only one way that this thing could look. It's going to go through these dots, and then eventually move downward towards that asymptote, okay? Now there is a question of, are we going to be coming back from underneath here, or are we going to be coming from up here? And the difference here, because both of those could happen, you have these things right here, and then you also have opposites. The question is it an even or odd multiplicity asymptote? If you guys remember graphing zeros and polynomial functions, sometimes you have a zero that bounces, and sometimes you have a zero that crosses. And it all has to do with the factor that makes that zero. Is that an even or odd multiplicity factor? Such as, here we go, come on. So like x plus 2 squared, the exponent is even. So this is an even factor, which would make a bouncing zero, okay? And then let's just say x minus 6. If you don't see an exponent, it's secretly taken to the first power. Secretly, don't tell anyone. And that's an odd one, okay? If it's odd, then your asymptotes are going to be opposite each other. If it's even, they're going to be matching each other. This right here, x minus 3, is odd because it doesn't have an exponent that is even. It's taken to the first power, which means that our line is going to be doing opposite things on this vertical asymptote. So if it's going down on this side, it's going to be going upward on the other side. So it's going to be doing this, and then we approach our horizontal asymptote going that way. All right? That is what that function is going to look like. The other things you have to know are the other cases of horizontal asymptotes. So what we did here, the degrees on the top and bottom matched each other. They were balanced. We have x to the first power on top, x to the first power on the bottom. Let me make up some space here. There's two other cases. It could be top heavy or it could be bottom heavy. One more second though. I'm going to do one more balanced one. Let's say that we have something like this. 2x cubed plus 6x minus 7 over, we're going to say x cubed minus x squared plus 8. All right? The degrees on the top and bottom match each other. They're both taken to the third, to the, the cubed power, which means that this is balanced, okay? So you want to think about, if x got really big, what will the numerator approach? What will the denominator approach? If x gets really big, 2x cubed is your most powerful term. Plus 6x is not going to matter as much. If x is huge and you're cubing and it gets massive, so this is just going to approach 2x cubed, and this one is going to approach x cubed, which we can simplify and get 2. So when you have a balanced degree on the top and bottom, you take the ratio of the leading coefficients. All right, that's what we just did there. Leading coefficients were 2 and 1. We took their ratio, we got y equals 2. All right, that is when they are balanced. So now I will, and once I'm finished with this little thing, we're going to go over Robot Dancer's questions and then also the Mandelbrot set. Yeah, we'll talk a little bit about it. It doesn't show up on the ACT or SAT, so we can't put too much time into it. But we can do a little bit. Yeah.
So are you done, or are you doing horizontal now?
Horizontal.
Very nice.
I've done 1/3 of horizontal. Gotta wait for this to dry.
Very nice.
Gotta dry. It's gotta dry. Gotta get all dry. It's getting dry around the edges. Still a little rough around the edges, though. Like Levi.
Yes.
You've been described as rough around the edges, right?
Yeah.
But you're really smooth in the center. You know what people say about you?
Yes.
Right. Okay, well that's good. Right?
Yes.
Ellie Kenobi. Ellie Kenobi. All right. So remember, it's all about the degrees on the top and bottom. If they're balanced, you take the ratio of the leading coefficients. If it is bottom heavy. Give you a quick example, you're going to see what happens here. If it's bottom heavy, we might have something like x squared plus 6 over 4x to the 4th minus 5. All right? Same deal. If x gets really big, what do these things approach? The 6 isn't going to matter as much. We're going to get x squared over the 5's not going to matter that much. We're going to have 4x to the 4th. All right? We can simplify this. We're going to have an x squared on the top and bottom that cancels out, which is going to give us 1 over 4x squared. Now remember that x is getting very big. 1 over something that's massive, as it gets bigger, will approach 0. So for bottom heavy, your horizontal asymptote is y is equal to 0. All right? And then lastly, if it's top heavy, like Levi. Levi's top heavy.
Yes, my lord.
Yes. X cubed plus 4x minus 6 over x minus 2. I need to save some space here. Well, same deal. X gets really big. What does this turn into? X cubed over x, which is x squared. Interesting. We're going to get an asymptote that looks like x squared. You're not going to get a horizontal asymptote. What you're going to get is called an oblique asymptote, which sometimes is a straight line. They call it a slant asymptote. So it might look something like you might have a vertical asymptote, you might have a slant asymptote like this. And so your rational function is going to look like this. All right? In this case, our oblique asymptote is a parabola. It's going to be a parabola that looks like y equals x squared. So you just have to find out what that is. And the way that you do that is you divide. You divide the top and bottom. If you want to do really, you want to get very detailed, you do polynomial long division or synthetic division to figure out what your quotient is, and that's going to be your oblique asymptote. But this one would have something that looks like this. And then I'm done, Levi, I swear. Horizontal asymptote at x equals 2, and then we're going to have a parabolic asymptote at x squared. And so what I'm going to guess this thing's going to look like is this. That's what I'm going to guess. Might be the opposite sides, but whatever. All right. I don't think there's any questions on that because you guys have not asked any questions thus far. So let's do...
Can you erase and I'll pull up Robot Dancer's question?
Absolutely. I'm glad you asked, Leave Word.
Me too.
Really?
Yeah.
Sometimes I feel like you're not glad.
No.
No?
All right. Wait, what?
Levi,
Yes.
do you like me?
Yes.
Thank you.
Oh my gosh. Robot Dancer. That's a lot of questions.
Robot said they had a lot of questions.
That's a lot more questions than before.
Robot dancer, robot dancer.
Ah. Oh boy. It's gonna be big. Oh, that's not what I wanted.
Transformers, robots in the robots.
Okay, so let's ignore the answer choices and make this nice and big. Ah. Ah.
Oh, this is still
Okay.
wet. Sorry, it's still a wet patch.
It's okay. Okay, I can't read through that. I can. So the number of coconuts grown. Oh, the number of coconuts grown, y, in thousands, is in this equation. Great. It can be predicted by the number of pineapples grown, x. Great, in thousands, from the line of best fit given by the equation above. Now I'm going to assume that all of these points on this scatter plot are over a certain number of.
Huh?
Yeah, I mean, there's a graph for the question. Oh, there is. Ah, that's nice. It's very nice. Oh, great. That helps enormously. Okay, let's just look at the question. I'm going to write the equation down, and then we'll get to the other stuff. So we have this equation, and this is the relationship between the number of coconuts grown and the number of pineapples grown. For what oh, did I really cut that off? Unbelievable. Ooh, I hate it. I hate it. I hate it. Okay. Sorry, Robot and everybody else. For what number of pineapples grown in thousands is the number of coconuts grown expected to be twice as much? Okay, so this is expected value, not
That's an expected
actual value. Sorry, not. It is the expected value based on the
Yes.
line of best fit. No,
Sorry.
it is not expected value as the
Probability
conceptual
thing.
term
Yeah.
in probability. Okay. So I don't really care about the graph
Nice.
because
I like where this is going.
the equation gives it to us. Maybe we can see it visually on the graph, but the best thing to do is use the equation. For what number of pineapples grown in thousands is the number of coconuts grown expected to be twice as much? So we want the number of pineapples. So we're solving for x. I can't write it there. So we're solving for x when the number of pineapples, the number of coconuts grown is expected to be twice as much as the number of pineapples grown, which means that the number of coconuts, which is y, equals 2x, right?
Yep.
We double the number of pineapples to get the number of coconuts. So we now have two equations. We have y equals negative 12 over 5x plus 12. And then we know this about it. So this is actually a system of equations. You don't necessarily have to think of it that way. You can think of it as, well, I know that I have x and I know that y is double x, so I'll just put that there. But that's actually this system of equations using substitution. Yes? So from here, we're just going to set these equal to each other, however you want to talk about it, but it's going to be 2x, I'll write it in pink now, 2x equals negative 12 over 5x plus 12. And then you solve that. I don't know what x will be, but it is a thing. Let's see, what are the answers here? Let's move it in and drop this down, 2.07. Yeah, so I guess when you solve for x, it's about 2.73. Do you want me to solve that, or are you happy with this here? Do you have any questions about this in general? Things like this. Do you like it? Do you not like it? What do you think? What is wrong with our... Can you check the chat? I don't think... Check the chat over there. Is it fine?
Yeah.
Okay.
There's a graph of the...
Solve. You would like to solve. Very good. Please. Thank you for the please. I appreciate it. Okay, so we're solving. When you're solving this type of thing, don't freak out because there are fractions. Don't get rid of fractions. Let's add 12 over 5x to both sides. We're trying to isolate x or solve for x, right? X equals other stuff, but we have two x terms, so we got to put them together. Luckily, we can. If we can't put x terms together, then you have to factor. Not the case here. So we're going to add 12 over 5x to both sides. 2x is the same thing as 10 over 5x. So now we're going to get 22 over 5x. 22 over 5x equals 12. And then we're going to multiply both sides by, I'm going to just make this into a nice fraction, 5 over 22. So this cancels, and we get x equals this thing. I'm going to simplify before multiplying, so I get 6 here, I get 11 here, I get 30 over 11. Which is about 2.73, I assume. I don't know if it actually is 2.73. I'm not good with my 11 division stuff.
2.73.
Exactly?
727272.
Okay, so it's not exactly. Okay, great.
Yeah. Now wait, why can't they get rid of the fractions to start with?
I just don't like getting rid of fractions. You could get rid of the fraction and say 12 over 5 is 2.4.
Oh no, I meant if you want to get rid of.
I was more saying just don't freak out with fractions. Like you don't have to make them go away just because they can't see that. So x is the number of coconuts. No.
No, they said the number of coconuts is y.
Yeah, the number of coconuts is y, but the question is for what number of pineapples? They said for what number of pineapples in thousands is the number of coconuts expected to be twice as much? So this y is coconuts and x is pineapple. Okay? So when you do, so we're saying that there are, for what number of pineapples grown, so we're solving for x the whole time, because that's what pineapples is. And for what number of those things is the number of coconuts grown expected to be twice as much, based on this equation. We don't need the picture because you could maybe look at it, but my guess is with the answer choices being close together, it's going to be a little bit difficult.
Do you understand y equals 2x, Robot Dancer? How Levi created that equation from that sentence?
I did explain it before.
Okay. And then another way to get rid of this fraction is to multiply everything by 5. So if you have a denominator of 5, if you multiply everything by 5, then you get 10x is equal to negative 12x plus 60.
Is that a new marker?
It was in the thing. I just have never used it before.
It looks really nice.
Yeah, thank you. And then you don't have any fractions to deal with there, and you'll get 22, 60 over 20. Yeah, you're going to get 30 over 11 the same way.
Very good. All right. Do you want to talk about the Mandelbrot set?
Yeah, you know what? Not really. The Mandelbrot set is pretty complicated, and we're an ACT SAT channel. I'd have to do some more studying up on it in order to accurately explain it.
It's like a fractally thing, right? Some sort of.
It is a fractally thing. It's on the complex plane. It's asking about complex solutions to a certain equation such that the solution remains bound or something. Just find a good YouTube video to explain it. I'm not the guy for the time. The time does not call for. I'm the hero that Gotham smells, not the one that Gotham deserves. What's the sentence?
I don't know. There's no way to be sure.
The hero that Gotham needs, not the one it deserves, something like that. So sorry about that if I got your hopes up. It's a little bit above my pay grade.
Yeah.
But I should do a little study up on that. But it makes a beautiful picture. You zoom in on it, and it keeps having this repeating pattern that goes on forever. And there's some great videos you can watch on YouTube where it's just trippy. It just zooms in over and over and over.
Okay, this looks fun. So we have the system of equations with q, x. Is that a v? No, that's a y. Okay, that's a y up top there. Y over q equals 2. So we have y, x, p, q. That's a lot of variables. In the system of equations above, p and q are constants, with q being positive. Great. So x and y are our variables. So that's good. That's okay. We're sorry for the blurry pig as well. It's fine. It doesn't matter.
I want to do this one.
Okay.
Very good.
Do you want me to explain it, though?
Yeah, I'm just going to stand here and
but you can do
this one. Well,
and
exactly.
we're very proud of you. We're very proud of you.
Thank you.
Careful.
Thank you. What? Do you ever think about all of the discriminant?
Yeah, I think about discriminants.
Yes. All right. So you got to remember what infinitely many solutions means. These are both linear equations. They're lines. Infinite many solutions means they're the same line. All right? No solutions means two lines never intersect, because solutions to a system of equations are intersection points. Points that the two lines have in common. All right? So, I didn't really write that well. No solutions means that they are parallel. They're never going to intersect. It means they have the same slope, but they have a different y-intercept, okay? If two lines have a different slope, they're going to intersect at one point. You're going to have one solution. If they are the same line, so one is right on top of the other one, every point on one is a point on the other. Points go on forever, infinite solutions. All right, just as an example, here's what that could look like. 4x plus 5y is equal to 7. 8x plus 10y is equal to 14. What do you notice? One of them is a multiple of the other, a perfect multiple. So you could divide all of these by 2 and you'll get that, which means that it's been the same equation the whole time. So what you need to figure out here is which equation here is just a multiple, and not which one, but one of these equations is just a multiple of the other. All right? Figure out what you need. Mean same y-intercept and same slope. Correct. Yes. That's right. If that was the case, they would be the same line. But more generally, this is what you have to remember. One of them is just a multiple of the other. Okay? So. Let's see what we have here. I'll put it right here. We have qx minus y over q is equal to 2. And we have y is equal to 9x plus p. All right, one of the tricky things here is that they're in very different forms. So I'm going to turn this one into slope-intercept form like this one already is. And that's going to make it a lot easier to digest. All right? So I got to solve this thing for y. Here's y up here. I'm going to get rid of this qx business first by subtracting it. So if I do that, I'm going to have negative y over q is equal to negative qx plus 2. All right, yeah, I took it away. I don't like all these negatives. I'm going to make everything divided or multiplied by negative 1, whichever way you want to look at it. So we're going to get y over q is equal to positive qx minus 2. Phew, I feel better now. Now I just have to multiply everything by q. So y is going to be equal to q squared x minus 2q. Great. Let's put this over here. So we have y is equal to q squared x minus 2q. Here is the system that we want to digest. All right, so like you said before, they have to have the same slope and the same y-intercept. Let's take a look here. Let's take a look here what we have. The slope of this one's 9, so therefore this needs to be 9 as well. Q squared has to be 9. So q squared is equal to 9. Possible solutions for q would be plus or minus 3. But they help us out because they say q is greater than 0. So therefore, it has to be the positive 3. All right? Q is positive 3. And then over here, we have that positive p is equal to negative 2q. I'm going to put that over here. Positive p, which is the y-intercept, must be equal to the y-intercept of this one, which is negative 2q. And now we know that q is 3. So p is equal to negative 2 times 3, which is negative 6. So if q is 3 and p is negative 6, these would be the same line, therefore infinitely many solutions. Robot Dancer, what are your questions? Or does it make sense? You are the one that must release us and let us move on to the next one. But only if this makes sense. If it does not, how do you switch negative qx to negative 2? So I think you're asking about solving this. I wanted to solve this for y. So I got rid of qx first by subtracting it. There is a negative in front of this, so this is going to stay negative. I subtracted it over here, so we have negative qx plus 2. And then I wanted to get rid of the negatives, so I divided by negative 1 everywhere. So I got positive y over q is equal to positive qx minus 2. And then the last thing is I need to get rid of this q by multiplying everything by q. So y would be equal to q squared x minus 2q. How did you switch negative qx? Does that answer your question? I don't think I ever switched it like that. I just did some manipulations. Oh, okay, also y is not equal to q squared. Because these two lines, they tell us, have infinite solutions, which means they're the same line. And like you said, that must mean they have the same y-intercept and the same slope. The slope of this one is 9. In this equation, the thing that represents slope is q squared. Remember, slope is the coefficient of x. Whatever's in front of x is your slope. So 9 and x squared have to be the same thing. These things will be the same, and these things will also be the same, because there's infinitely many solutions, which means they're the same line. I understand. Very good. Levi, want to do the next one?
Yes, I do. Don't you?
I want you to do the next one. Alan's here. Alan! Alan!
Alan, get out of here before Brady makes the joke about your name.
Alan, I never showed you that video, did I?
Me?
Yeah.
I don't really want to see it.
Why?
I saw the first episode.
You're just unbearable, Levi. I would never start a business with you.
No?
No, not in a million years.
Do you even hear yourself, Bird?
Of course.
How is that for you?
This isn't a business, man. This is free. I would do this all day with you. Man, you're a businessman.
We got a little bit of this.
Gotta let it dry.
You know what? I'll just stick with this.
Gotta let it dry.
This is a hard question. I think it's a little bit confusing, more confusing than the SAT would be.
Alan! Durander, who are you? You must tell me who you are. I must know.
Is that good, Bird?
Well, if you want, you gotta have a little headspace.
Yeah, I'm gonna do it then.
I'm just ignorant and racist.
Yeah, I got you. Okay. So we have a building on flat ground, uses a drain pipe to carry stuff. Great, so there's a drain pipe. That's basically what we're dealing with.
Drain pipe.
Drain pipe. And what's misleading about this question is that it says that it drops between 1/8 of an inch and 1/4 of an inch every foot. Yeah, at least 1/8 of an inch it drops every foot it goes across, but it can't drop more than 1/4 inch, because remember a quarter is greater than an eighth. And then it says in the first 12 feet the pipe drops 2 inches. That is not how much that's not the same rate at which the pipe drops for the rest of that time. Okay, that's not what that is. Also, we do need to keep in mind that we are not comparing the drop or the change in y value if we were going to make this picture on the xy plane. The x term is not the horizontal distance, it is how much pipe you have. So I'm not going to do this as a graphing problem because I think it would be confusing. I'm going to do it as a rate problem, okay? And the answer choices, which if you want to see the answer choices, I'll bring them up at the end. Durana, what's going on? Okay, so rate, that's what I want to do. Rate equals distance over time. In this case, our distance and time are basically in the same units. We drop a 1/4 inch or 1/8 of an inch. So this is the drop. So that's actually nice that stands for D. And this is the pipe distance. And that's the rate at which we go. So this is what I want to do. I want to make this into RT equals D. RT equals D. Because I want to know how far down we're going. Right? This is how far down we go each time. So we have a rate of 1/8 of an inch for every 1 foot of piping. I'm going to change the foot of piping into 12 inches because I want everything to be in the same units, and the question is asking, I think, for units. Yeah, possible pipe below ground in inches at the end of the drain pipe. So let's figure out the low end. It needs to be at least 1/8 of an inch drop for every foot we go across. So, oh, you know what? I think I mislabeled this. This is, no, this is fine. This is fine. But that may be misleading. We'll find out. So the rate at which we're dropping for the 1/8 of an inch, so we'll do this one first, is going to be, yeah, whatever. I'm going to do this in a different color. So this will be the 1/8 inch over 12 inches. And how far are we going? Well, we already did 1 foot, right? Or is it over the first 2 feet? It's over the first 2 feet that we already have those 2 inches. So we're going to ignore that. We don't have that left anymore. So the total drop is going to be this D here. So drop equals 1/8 of an inch over 12 inches. That's the rate. I will label that real quick. This is D equals R times T. And the T, as we said, is the pipe distance. We have gone 104 inches. Sorry, that's 104 feet. So I'm going to convert that into inches. So I'm just going to do that over here real quick. So 104 feet times 12 inches over 1 foot is, Bird, what's 104 times 12? 1,248. So 1,248. Are you with me so far, Robot? And everybody else? 1,248. Please let me know if that was wrong.
No, that's right.
It's right? Okay. 104. Did that just happen?
What?
The robot's comment.
I don't know.
Okay, so yes, you want to put 104 feet here. I'm not sure when you made that post, but I just changed it into feet, from feet to inches because I wanted it in inches. Okay, so now this is going to be the drop if we're at 1/8 of an inch per foot that we drop. Okay, please let me know if that doesn't make sense because that is hard. And then I'm going to do the same thing again. I'm going to squat down also. We have, for the 1/4 inch, I'll do it over here. The 1/4 inch rate. How did it become 104? Oh, gotcha. The 104 came from the fact that we have 106 feet of pipe overall, but they said that, I think the second to last line, in the first 12 feet, the pipe drops 2 inches below ground level. So they're saying that this is why this problem would not be on the SAT, or it would be much clearer. What they're saying is we drop 2 inches in the first 2 feet, and then after that, we are still variable. We don't know how much we're dropping or not. So we know we're going to drop 2 inches in those feet, so we have 104 feet left over. That's what this is. This is the lower end, if it's not dropping very quickly. I hope that explains that. Let me know if it doesn't, and I can try again. Now, we're going to do the drop 2. So this is drop 1 for the 1/8. This is drop 2 for the 1/4. This is going to be the bigger drop. So we have 1/4 of an inch for every 12 inches of pipe. And how many inches of pipe we have is 1248 inches. So inches cancel on both of these. This is going to be equal to, Brady, I may need some help, 1/8 divided by 12 times 1248.
13.
13. Wait, actually, I don't think it matters. 13? I'm going to check the answer choices because the answer choices will say something. 106 minus 12 over 8. That's the 1/8. That's the 1/4. Oh, it's in the first 12 feet. Ah, okay. Your question makes a lot more sense now because I don't know how I misread that, but it's not in the first 2 feet, it's in the first 12 feet. Dang it. Okay. So this is wrong. I'm just, at this point, I don't want to take too long on this question because I think it is more confusing than you would ever see on either test. So I'm going to write up the answer choice, or I'll just show the answer choice and then I'll talk you through it. So, this 2 here, okay, is the 2 inches that, because this is asking for the range of inches that this pipe could have dropped at D at the very end in the picture, on the very far side. So we have the 2 inches, and then we have 106 minus 12. That's the number of feet we have, minus the 12 feet we've already gone, divided by 8. Because we're going 1/8 of an inch for every foot we go down. So that's technically 2 plus 1/8 times the total number of feet minus the 12 feet that we already took off, and that's where we got this 2 inches down from. In those 12 feet, we went down 2 inches. So we went down this much, and then at the very least, we went down 1/8 of an inch for all this. This 1/8 is now just put on the bottom, so it's 106 minus 12 over 8. Does that explanation make sense? Now that I've ruined it by getting the wrong numbers from this problem. And then the other side of the inequality is the same thing, except instead of 1/8, it'll be 1/4, so it's just divided by 4 on the bottom. Do you have any issues with that idea here? Dang it. Brady, did I ask, do you get it, or did I ask other questions?
I don't know.
No. Okay. I think we're good. So I'm going to go on to the next question. No, this will not be on the test. Nothing. I mean, the idea of figuring out a rate and the extremes on both ends, making an inequality. Sure, this level of confusingness, it will be more straightforward than this. Not necessarily by a lot. Okay. Do you want to do the next one?
Yes.
Okay, let me pull it up for you. Oh, get out of here. Bam. Ooh. Maybe you should dress up a little.
I have a child, actually.
Oh, right now?
I forgot, yeah.
Dude, it's good that you remembered.
Yeah. Big time.
Bye, Birdie.
Goodbye, everyone. They can't even see my body anymore. Pull it all the way down. You can. Okay, never mind. Goodbye, Leafwood.
Goodbye. What do we got? Have fun with the child. Word choice. Word choice. Robot dancer. Okay. I'm going to start erasing this and start reading this problem. Not had a chance to look at this. So the figure above shows a sector O with radius R. Okay. If the area of the sector is 3 pi, what is the approximate perimeter of the sector? Okay, so Robot, when you tried to go for this on your own before, what things did you figure out in the service of this problem? Because I definitely recommend throwing stuff at this type of thing. Circles don't have all that much information in them, so I want you to start throwing things at them, especially with sectors that might seem to make sense or things that you can figure out that may or may not help you find the answer, but may give you a little bit better footing. So what do you know? If we know the area of the sector is 3 pi, can you tell me anything else about the circle that you could figure out? I was confused because I thought they wanted the perimeter of the open area. The open area. What do you mean by perimeter of the open area? I mean, I would be confused too if they asked for that, because I don't know what that would be. Yeah, they want the perimeter of the sector. So they want, the 3/4 of the circle, and then they want that, and then they want that. I'm going to draw a little map for you. I thought 1/4 of the circle. I don't know why. Great. Okay, do you want me to go over this one or no? Do you think you can figure it out on your own? Because I'm happy to just skip to the next one. Also, other people who are watching, please ask your questions. I'm happy to keep answering Robot Dancer's questions. That's fine. But you can put your questions in the Discord, or you can ask them in the chat, or whatever. Okay, we'll go over it. I will keep answering Robot's questions, and if anybody else asks questions, I will put them in before the next one I do of his, because I'm sharing the love. All right. So we know that the area of the sector is 3 pi. We need to get from there to the perimeter of circle. Yay, welcome back, Storm. Pi r squared equals 3 pi. Careful. The area of the sector is not the area of the circle, right? The circle is less than that. So if we're trying to find the perimeter of the circle, what do we need to know? I got a 25 on my most recent ACT. How do you feel about that 25? Are you pleased? Are you trepidatious? Do you hate it? Do you love it? What are your thoughts on it? Think you can do better? 3/4 pi r squared. Yes, exactly. So you just said that this equals 3/4 of pi r squared because this is the area of a circle. Cool. Then let's get you up to speed. This will help you, this problem specifically. Okay, so we know that we have 3/4 pi r squared. So what's next, Storm? Wonder about doing a going to find out about that. Find r. Yeah, so let's solve for r. So I'm not going to wait for you to tell me all the steps because that'll take a long time. I'm going to get rid of this so we have a little bit more space. So hopefully you would have done these same steps. Let's get rid of the 3/4. So we'll multiply both sides by 4/3. That cancels with that. So now we have pi equals pi r squared. We now know that these cancel, right, because they're just pi's, so whatever. So now we have 1 equals r squared. So now we take the square root of both sides. 4 pi. Nope. Square root. We get 1 equals r. Where did you go wrong to get the 4 pi, do you think? And then what do we do from here? We now have the radius. How would we find the perimeter of this circle, or sorry, of this sector? You didn't cancel it out. Dang it, what did I not cancel out? Oh, you didn't or I didn't? Did I mess up? That goes away. Oh, there's a 4. You were just telling me 4 pi. Duh. Yes, right. 4, 2. Yes, I'm ashamed. Thank you. Okay, happy? I feel bad. Making so many mistakes today. All right, so r is 2. Now from there, let's find the perimeter of, the sector is what we're doing. Yeah. So let's find the perimeter of a circle first, and then we can cut it up. So the perimeter of the circle equals, it's supposed to be a circle. I don't know how else to, whatever. The perimeter of this circle is going to be 2 pi r, yes? So it'll be 4 pi. But it's not going to be 4 pi because we only have 3/4 of it, so it'll be 3 pi. So the perimeter of the sector is 3 pi because it'll be 3/4 of that, right? Let me know if that doesn't make sense. And then we need to add in the radii. So it's going to be that plus 2 times r, which is 2, so we have 4. So this is going to be this is 3.14, so it's a little more than 9, so 10-ish plus 4. It's not 10-ish. I would say it's about 13.4. Yes, okay, so we know we have a sector here. So we have a circle. We know the radius. That's not where I should draw that. We know the radius is 2. So the perimeter of this circle is 4 pi. Yes? 2 pi r, pi d, whatever it is. So the perimeter is 4 pi. But we just want what's around here. So for the exact same reason that up top you said that the area of the circle is 3 pi. No, sorry. The same reason that you did 3/4 of the area up here, we take 3/4 of the perimeter. So the perimeter of the sector, or just that piece of the sector, the outside, the circly part, will be 3/4 of 4 pi. Cancels, we get 3 pi. Make sense? I like this question. It's cool. And we just added the 4 from these pieces here. There and there. Thank you for saving me along the way with forgetting that. Okay, next one. Nobody else has asked the question that I can answer. Wait, actually, I should check that. Give me a sec. Did any of you people ask More Discord questions? No, it looks like a lot of Robot Dancer. All right, it's just private tutoring with Robot Dancer and Levi, and everybody else gets to spectate. That is fine. Okay. Nope. Oh, whatever. Just... Oh, also, now's a good time. This is Alta Ipsum. It's our sponsor. They are an app, and what they do is they let you use them for free, and it allows you to, it means summit yourself in Greek or Latin or something like that, and it allows you to track your grades and plan classes and set up a schedule in a planner, and so you can put in when you have a test or something like that, and it'll make up a study schedule for you, which you can then manipulate from there. But it's very nice. It outsources work to something else, and then you can just focus on what it tells you to do after that. Just be careful of it becoming self-aware. It's always a worry with grade tracking apps and the like. Oh, pretty close. Nice. Nice. A little bit of extra stuff here, and a little bit of extra stuff there, and Nope, that's not what I wanted. Sorry. There we go. That's big enough, right? Emily traveled 60 miles on the highway and 16 miles on the local roads to reach her destination. On the highway, she traveled 30 miles faster, 30 miles per hour, I assume, faster than on the local roads. If her speed on local roads is 20 miles per hour, then what was her average speed in miles per hour during the entire trip? Ooh, fun. That question you're doing right now, I believe, is worded wrong. She traveled 30 miles faster than this book wasn't from a corporation, but an individual person. Oh, interesting. Yeah, I would guess it should be she traveled 30 miles per hour faster than on local roads. That would make sense, so I'm going to assume that. Let me know if that doesn't make sense to you. So, we have highway, 60 miles on the highway and 16 miles on the road. Okay, so let's draw this. 60 miles. And then, let's do pink. Everybody likes pink. This is what you came for, watching me marker cap things. And then we have 16. This is not drawn to scale, clearly. So, 60 miles on the highway. This is local. This is highway. Let's just double check that I got those numbers right. 60 miles on the highway, 16 miles on the local road to reach her destination. Great. On the highway, she traveled 30 miles per hour faster than on local roads. If her speed on local roads is 20 miles per hour, so this is the rate equals 20 miles over 1 hour. I like writing things like that because it keeps you in the mindset of fractions and doing unit conversion stuff with multiplying by 1 of 12 inches over 1 foot or 1 foot over 12 inches, depending on what you want to cancel out. Yes, you should. Yes, you should. It is not a dumb thing to do. It makes it clearer. I do it to make it clearer for you, but also when I take tests, because I try to take the tests for the first time when they come out and not work through them because I like just seeing how I do and putting myself in that situation to understand. Blah, 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 blah. So yeah, draw stuff. You are outsourcing, just like Alta Ipsum, you are outsourcing the work to the paper. If you can see it, it helps. Don't try to do everything in your head. Trying to do things in your head because maybe you don't like math, you don't like the problem, you're trying to make it go faster, so you just do it. You will make mistakes doing that. Of course you will. Draw stuff. It maybe makes it a little bit more fun too. Okay, so 30 miles per hour faster. Okay, so that doesn't actually make the problem harder. It might feel like you're supposed to do something there, and because it's worded incorrectly, it makes it even harder to realize. But this is just going to be, I should do it in the other color. Now, you won't be able to color code on the test, but that is what it is. Rate equals 50 miles for 1 hour. Jeff, what's up? Thank you. We're glad it's awesome. If you or your children or parents are taking the SAT or ACT, let us know and ask your questions. But I'm clearly responding to you right now. This is somebody on Facebook, for those of you not on Facebook. Ask me questions, throw it in our Discord, which should be linked somewhere around the video in one of the channels, or ask someone in the Discord if you know what Discord is. Or you can just ask questions in the chat, whatever. Okay, so this is where we're at here. And now they're asking for the average speed, right? Now, speed is rate, yes? So this is actually a little bit simpler than my parents are taking the SAT. They are 17 and I'm 3. Very good, robot. You are very well spoken for a 3-year-old, if I do say so. Is this dog ears, by the way? Wait, that would go the wrong way. Dogs do their own thing. Okay, so we want the the overall speed. So the rate, I'm going to do rate overall. Does overall have 2 L's? I don't actually know. I think it does, right? It should. I'm so bad at spelling. Okay. I know you're lying, by the way, robot. Just putting that out there. So this is going to be distance over time, right? That's what rate is. So these rate problems, they are simplified by drawing stuff, and also they're simplified by this is always there. For whatever reason, we don't do this much, or you don't do this much in high school anymore. You did it when you were in probably middle school more, and then you just drop it. But this is super important for these questions. So we know the distance, right? The distance is 76 miles per hour. So this is going to be 76 miles over the time. How long does it take? So that's what we need to figure out. But if we have r equals distance over time, we need to find out the time, and we need to find out the time for each piece, right? And each piece, we can find out the time because we have the rate and we have the distance. So we have 2 of the 3 variables for this equation. So that's what we're going to do. We're going to say that here 50 miles over 1 hour equals 60 miles over x hours, okay? And then we solve this. This just kind of goes away. It cancels out with the h anyway. And then the zeros cancel, the miles cancel. And so x, which will be in hours because it's going to be what it is going to be 6 over 5. So we're multiplying by x on both sides, so we get 5x. I'm just showing my work, equals 6. Let me know if this doesn't make sense. So x equals 6 over 5 hours. How did I manage to screw that up? Okay. Does this idea make sense? 6 over 5 is 1.2. So I'll just do it that way. So we have 1.2 hours plus, now we don't know how many hours. So that's because we have overall time here. So the overall time will be this time plus whatever this time is. Let me know if you are lost at any point. So here we have the rate, which is 20 miles over 1 hour. I like keeping track of all the units. It's not absolutely necessary in this case, but it does keep away from getting some mistakes. So this equals 16 miles over x hours again. So miles, miles, hours, hours, 1 goes away. And then let's just do it. So let's multiply by x on both sides. So we have 20x equals 16. And then x equals 16 over 20, which is 4 over 5, which is 0.8. So plus 0.8 hours. So this will equal 76 over 2 hours, which will be, if we simplify this, 38, this is miles, miles per hour. D. Okay? So, visualize stuff. When they ask for overall speed, you're getting just, if you, what simplifies that in your head, because your first thought might be, okay, I need to find some way to reconcile the 30 miles an hour over this distance and this 60 miles an hour over this distance to find the average speed for the whole trip, and that is hard to do for sure. I haven't even thought about it recently. But if you know this part of it, you know that you just need to find the overall distance and the overall time. You can do those piecemeal and get to here. Do you have any questions? I don't understand the concept of finding x. Oh, got it. Okay. Shoot, why did I do x? That was stupid. That was really foolish. This should be t. So I'll just leave that there. So another way to show this is it is rate times time, or rate equals distance over time. Your rate is this, right? That's what I said here. So you have 50 miles per hour is your rate. Your distance that you go is 60 miles. So how long does it take you is t. Okay? And so t equals 1.2 hours. That's what you get there. And then for the pink one, you have rate equals distance times time. The rate is 20 miles per hour. The distance is 16 miles. And the time is going to be a different t now, and it'll be t equals 0.8. Yes, it's the time. That's totally my bad. I should have made that variable t because I don't know why I would make it x. I wasn't paying enough attention. Questions on that? Anybody else? If you have a clarification question, your name is not Robot Dancer. Not that Robot Dancer's name is Robot Dancer. Please let me know, and I'll explain it. Otherwise, I'm going to start erasing these things and do the next question. You should also ask your own questions. Let me see. Do we have any other Discord questions? No. Nobody new, so it should be good to go on to the next. Great. Okay. I like that question. What is this? What's the question? Six. I'm confused. Oh, I see. Okay, I'm not confused. Give me a sec to erase this. I'm going to see if I can memorize the answer choices and then go back to the... So it's no change, right? Okay, so no change, and then we have these three guys. Let me... What do we got? So for number 6, I used a colon because it contains a list. Okay, tell me real quick, what is the rule for colons? I think it's been a while since we talked about this with you watching Robot, but because we've been doing a lot of math with you, when can you use a colon? What do you have to have? I'm going to start looking at these answer choices. Through speech, song, and folklore, through speech, song, and folklore, and then through speech, song, and folklore. What is the difference between B and D? Oh, God. Okay. All right. So there is a simple reason that number 6 is not C. And I will tell you once you... Do you remember when you're allowed to use a colon? Colons are not only used for lists. That is not the only reason, and it is not a good enough reason to use a colon. Complete sentence before the colon. Yes. Mainly used for definition and list. Sure. Yeah, you could say that, mainly used for that. It's generally the first idea, colon, then it has set up the second idea. So I love school, colon, I get to see my friends. Something like that. So... in this sense, so I'll go to the passage. Might as well just get 2 of these. Can you see what? No, you cannot see what we need to see. All right, so hopefully I can figure out what this sentence is. All right. We have, her work reflected this exposition as she sought to capture what she termed the natural art of African American something through. Okay. So here's your problem. You don't have a full sentence before. Yes, you do want to say through speech, song, and folklore, but you have to have an independent clause that can stand totally alone before the colon. You cannot end a sentence with through in this way, okay? You could say think it through or something like that, but you would not say I learned about turtles through a translator and a professor. I don't know why this would be your sentence necessarily, but this doesn't work because by putting a colon here, you are saying that you have an independent clause here, which you do not. You cannot say, I learned about turtles through. Okay? You can't say, I like fruit such as. You can't do that. You have to have it be by itself. Independent clause is subject and verb, which we have, which we do have there as well, but it has to be a complete thought by itself. It is not, you are setting something up, but you just have to keep going. I learned about this through a translator and a professor. Nothing. You don't want anything there. Through this, by this, under this, whatever it is. You have that prepositional phrase. You want to keep it all together. So I would not use a colon here. I would use nothing. And then I think, so I don't like 6 with no change because I want commas between these things. We have speech, song, and folklore. Those are 3 things. You have to put commas between them. So it should be through speech, comma, song, comma, and folklore. That's, I think, the correct answer choice. Notice that you have an and, so you don't actually have to put the comma after song. That's called an Oxford comma. If you do that, they will not test you on that. You can choose, but you have answer choices, so you'll have to choose what they give you. There may or may not be a comma after the word song. There's definitely not a comma after the word and, so whatever answer choice that was is wrong. You want through speech, comma, song, comma, and folklore. That's the right answer. Do you have any questions on any of that? The most important thing is colons. Do not say, I know when contextually to use colons. Sure, but that's not as important as when you have to, when you're not allowed to use colons. You're not allowed to use them if you don't have an independent clause like we don't have here. Yes, questions, thoughts, concerns, dreams, ideas. Remember that independent sentences must go before a colon. Yes, this is true. This is what I have been saying. Matthew, ask me a question. Or don't. I mean, whatever. What would be an example of an independent sentence in that context? You could say, her work reflected this exposition as she sought to capture what she termed the natural art of African American literature, through speech, song, and folklore. You could say that. I don't know why you necessarily would. I wouldn't put anything, but you could. You have to have an independent clause. For this, you could say, I concocted a potion by night, day, and dusk. That's totally cut off. I'm going to turn this off real quick. Make sense? Can you explain why that wasn't an independent clause again? Yes, you can't just say, so forget about other stuff. When you're checking an independent clause, ignore the rest of the sentence. So you can't say, I concocted a potion by, right? It's not that a colon sets up a list. A colon sets up something following an independent clause. by ending your independent clause with the word through, it's no longer independent. It requires you to say something else, right? I love fruit such as apples, bananas, and pears. Where do you want punctuation in this sentence? Where would you like it? What would make you happy here? If I'm asking you to use a colon, where should you put that colon? After what word should you put that colon? After fruit. Yes, exactly. You want to put it after fruit. Yes, the list is over here, but you need to put it there. You can't put it here. If you put it there, can you see that? If you put it there, you have I love fruit such as. Okay, such as what? It's not an independent clause. It can't stand alone. So, no colon here. You have to put it after fruit. I love fruit. Subject, verb, object. You don't need an object for an independent clause, but I love fruit is perfectly fine on its own, such as apples, bananas, and pears. You could do that. You could feasibly put a comma. And you want commas here too. Or you definitely need that one. You don't have to have that one. You could put a comma there. That makes this non-essential, which we've talked about. That's supposed to say non, not whatever it looks like. Okay, any follow-up? So whatever is before the colon is not a complete sentence. You don't use it. Yes. Okay, so every single time. Here's an example. Incorrect. On our trip to London, we visited museums, palaces, and monuments. Good. That's no good. Correct. On our trip to London, we visited these tourist attractions. Museums, palaces, and monuments. Perfect. Does that make sense? Robot, do you understand that example? Great. So whenever you see, here's the thing with the writing section of the SAT and the English section of the ACT. Also, Ring Matthews, are you taking a test or are you just hanging out? I forget. I've met some new viewers recently, so I forget exactly where everybody's at. Obviously, that was incorrect grammar. The SAT and ACT, what they do nicely is that they give you the right answer, right? It's going to be there. They're also going to give you the wrong answers. So you don't have to think, okay, what's the best way to do this sentence? What you have to do is say, do I like this one? 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 And you look at the easiest ones first. So I'm gonna pull up an SAT and we're gonna talk about it, okay? Are you guys doing SAT or are you doing ACT? How are you feeling about either one? Or which, I know Robot is doing SAT, right? I can pull up an SAT and I want to go through how to approach a specific, any given specific punctuation question, one of the ones where you have a colon or a semicolon or a period or a dash or a comma or nothing or one of those type of deals. I'll start finding that for you. This is SAT Practice Test 8, by the way, that I got. Nobody's answering. Fine. This is good. I like this one. Not close. I can't enjoy these streams properly because my Wi-Fi is so slow. That's super annoying. Sorry about that. Is the worst. For number 5, I didn't know what to put because I didn't know what they meant. Number 5. Are you talking about this test specifically or are you talking about another test? Or are you just talking about the ones you posted? Okay, I'm going to do this real quick. Whoa, what's going on? Switch to YouTube, it's much better. Oh, thank you, Alan. That's interesting. The one you posted. Okay, we'll hit that in a sec. All right. So these. Thank you. See you, Kuze. Can I comment on YouTube? Yep, I can see the comments on YouTube. Obviously, nobody on Twitch will be able to see them, but I have Restream, which just gives me all the comments, so I see everybody on Facebook, YouTube, and Twitch. I may or may not explain what's going on. I normally don't for the Twitch comments. For the YouTube and Facebook comments, if they come in, I'll say that. Be a little bit more clear. Wait, what did I do? Need a little bit more, don't I? Too much. Better? Oh, no, this is not what I want at all. Stupid. It's not what I wanted to do. No. Am I not going to get one in this part of the test? That'd be so annoying. I don't want to do that one either. Great. Great. Bear with me. All. Please. Yada, yada, yada. It's very exciting, right? I'm very excited. Yay. No, that's too easy. Really? Yes. Okay, 29 it is. What have I done? All right, here we go. But yes, please comment on YouTube. All right. So we have, oh my gosh. No. This is all, really? Am I really not going to get a simple question on this one? Wow, unbelievable. Okay, practice test 7. Sorry, everybody. Okay, number 4. That's what we're doing. Great. B. I'm sorry, you're probably answering the wrong one. All right, number 4. We have semicolons, we have commas, and they're in different places. I say always start with the easiest punctuation. Semicolons are easier than commas. Commas are the hardest punctuation. So if you see a semicolon or a period or a colon, do those answer choices first because it tells you where to look. You can figure these things out, but it's nice when the question tells you where to go so you're not wasting time on frivolous pursuits of if you're looking at the wrong part of the sentence, thinking the wrong thing. If you see a semicolon, you know you're dealing with independent clauses. So let's look at B. We have semicolon, and then we have the word and. So let's read this. Do we have an independent clause before the semicolon? Because we need it on both sides for a semicolon. But by initiating and collaborating on projects such as the Apollo moon missions, the Space Shuttle program, the Hubble Space Telescope, nope, we don't have an independent clause. We had a dependent clause by initiating and collaborating on projects such as the Apollo moon missions, comma, so this is DC, comma, IC, let me know if you don't know what that is, dependent clause, comma, and then we want our subject and verb. So we have, but by initiating these things, the Space Shuttle program, the Hubble Space Telescope, and unmanned planetary exploration, such as the Apollo moon missions, the Space Shuttle program, the Hubble Space Telescope, and other stuff. So we don't have a subject in the first part of this sentence before the semicolon. So B and C are out. We have A, we have B, we have C, we have D. Hey, Ring Matthews, if you're here, I haven't gotten a comment from you on Facebook, on YouTube. So B and C are no good, right? Because the semicolons don't work. We don't have a subject and verb before. There are verbs, but they're not the active ones. The verb is, the subject and verb is, NASA has continually challenged its scientists and engineers to do things that were previously thought impossible. Everything before that is the dependent clause. By doing all this stuff, such as this, and this, NASA has continually challenged. That's the main independent clause of the sentence. So That means now we're looking at commas, okay? That is the approach. Semicolons first. There are no periods in this one. There are no colons in this one. Then we go to commas. Do we want the comma after and, or do we not want the comma, or do we want the comma before and? We have the Space Shuttle programs, the Hubble Space Telescope, and unmanned planetary exploration. I would say you want the comma after exploration or telescope, not after the word and. Yes. Okay. So I hope that makes sense. Please ask me questions if it doesn't. But I'm going to do robots next question unless somebody else has asked a question in the Discord. Please do. The answer here is A. But the approach, comma fanboys. You want to talk about comma fanboys? Is that what you're saying? Oh, this is not comma fanboys. How should I study for my AP US history test? Well, you know, I'm not necessarily the person to ask. I got a 3 on my AP US history test because I'm very bad with dates and when things happened. Very bad. I was wholly unprepared for that test. Incredibly. I just truly had no idea. Any wars? Didn't know. Yeah, Crash Course is good. The essays are a good idea because those do go into your score out of 5, and that's where you can help yourself out. They do have decent leeway in the multiple choice section, I think. Yeah, the DBQ is hard. I remember that. Ooh, DBQs. Hated those. Okay, back on topic. Nobody seems to have questions about this. So, oh, wait, no, that's not true. The comma and. All right, so comma fanboys. You do have for and. Yes, you have that. That doesn't mean that every time you see a comma and that it's comma fanboys. Remember that you can have comma and in a list. When we have lions, comma, and lions, tigers, and bears. Scare me, I guess. This is obviously grammatically correct. Lions, tigers, and bears scare me. Sure. But are we going to say that this is a comma fanboys? No, because lions, comma, tigers is not an independent clause, of course. It's just two nouns. So we don't have a verb, so it's no good. But that's not what this is. This is an Oxford comma followed by an and, so just ignore it as comma. It's not comma fanboys. That it could happen. You could say lions, tigers, or bears would be fine. I don't know why you'd say that, but I don't want to meet any lions, comma, tigers, comma, or bears. Just be aware this can sometimes, comma fanboys could show up as part of a list, and then it's just not comma fanboys. That should clear it up. That's a relatively simple thing to understand, but it does come up, and I have not explained that to you. But that's important to know. It should be relatively easy to differentiate when you see those things. Wow, it's late. Okay. I went way too... not that... It doesn't matter. Okay, I'm going to call it for tonight. Is today Wednesday? Yes. Okay, so I'll be back tomorrow. Come with your questions. Good luck on the AP US History stuff, Trapsy. Trapsy, you're being very cordial right now, which wasn't the case earlier. That's fine. Don't mind. Very rugged and resilient like that. That's what my mother says. She's never said that. All right. So yeah, come with your questions. Do some practice tests, and then come with the questions that tripped you up. Try to identify question types that are hard for you, because if you just hit a really hard question that's a question type that you get and you're good at the approach, and it's just a hard one, then yeah, we'll go over it so you can see the hard concepts that you're missing. But it's more about the approach to the specific types, and then different concepts that are tough for you that are very common on the test. We'll go over those as well. Okay, gonna sign off. See you tomorrow, or not, one of those two things. Yeah, great. Have a good night, everybody.